Hey everyone, today we'll be going over titration curves again, but today we'll be going over the calculations. And yeah, these calculations can be a bit tricky, so let's go over them. Okay, so we're going to start off. Okay, so we're going to consider the titration of 15 milliliters of 0.2 molar nitric acid with 0.1 molar sodium hydroxide. Calculate the pH when no NOH has been added. Well, this is just a simple strong acid calculation. So let's just write the equation down. And we know that H plus ion concentration is going to be 0.2 because this is a strong acid. When you plug that into your calculator, you should get 0.699. And unfortunately, things are only get harder from here. So yeah, that was really easy, but that's before any base is added. Things get really complicated once you start adding that sodium hydroxide. So what happens when 10 milliliters of 0.1 molar sodium hydroxide has been added? Well, things are going to get complicated because you're going to have to take into account of the hydroxide ions and the change of volume. So the first thing I would do is find how many moles of stuff we have. So moles of H plus ions, well, that's just going to be 50 times 0.2. That's going to be 10 millimoles of H plus ions. And for hydroxide ions, we do the same thing. It's going to be 10 times 0.1. That's going to be 1 millimole of OH of hydroxide ions. So now H plus is going to react with OH minus to form water, agua, and then so let's do initial and final. So it's going to start off 10 here, 1 here, and that stuff doesn't matter. What's important to know is that these two are going to react, so they're concentrated. The amount of moles is going to decrease. So this is going to go to 9, and this is going to be 0. And this doesn't matter. So now we know that we have 9 millimoles of H plus. Okay? But this is only part of the problem, really. We have to now find the H plus concentration using the volume, and after that we have to plug it into the equation to find the pH. So the new volume, it's going to be 50 plus 10 because we just add 10 milliliters. That's going to be 60 milliliters of stuff, right? And now to find the concentration, we do 60 milliliters. We do, 9 for 60, which is equal to 0.15. And then pH is equal to the negative log H plus concentration. Negative log of 0.15, which is going to equal 0.82 if you plug into your calculator. So yeah, can be a little tricky. So let's do another one just to make sure you get this. Okay, this time I'm going to be really fast because we just went over it. So let's calculate moles of H plus. Well, this is going to be the same every time, actually. So from last problem, we know it's going to be 10 millimoles. But now the moles of hydroxide is going to change because we're adding more. We're adding twice as much this time, so it's just going to be 2 millimoles. So, so the remaining moles of H plus after the reaction will be 8 millimoles of. So 8 millimoles of H plus will remain after it reacts with the hydroxide to form water. So yeah, now we know that we have 8 millimoles of H plus. Let's just write that down at the bottom. And now let's do some more calculations. So the volume now is going to be 50 plus 20, it's going to be 70 milliliters now, because we're adding, we're adding 20 now instead of just 10. So now we can find the H plus ion concentration, which is just going to be 8 over 70, which is going to be 0.11. And now we can finally calculate the pH. And if you plug this into your calculator, you should get 0.942. So as you can see, the pH is beginning to increase. Okay, now for a little different situation. Now 100 milliliters of 0.1 molar sodium hydroxide is added. Well, from the other problems we know that the moles of H plus is always going to be 10 millimoles. But now there's also 10 millimoles of hydroxide ions. Okay, so yeah, now there's an equal amount of H plus ions and an equal amount of OH minus ions, and this is called the equivalence point. Equivalence point. Okay, and because we're titrating a strong acid with a strong base, we know that the pH at the equivalence point is going to equal 7 because they're going to neutralize each other. Okay? So the pH is 7. Yeah, this is the equivalence point, and this is what you'll probably be asked about the most. So, make sure you get this. Okay, now things are getting a little weird. Now we're adding 150 milliliters of 0.1 molar sodium hydroxide. So now there's going to be more hydroxide ions than H plus ions. So we already know that there's always going to be 10 millimoles of H plus ions. But now there's going to be 15 millimoles of hydroxide ions. And so, yeah. So what's going to happen? After these two react, there's going to be 5 millimoles of hydroxide ions left over. Okay. But now, yeah. So now instead of finding the concentration of the H plus ions, we're finding the concentration of the hydroxide ions. So we can do this by simply dividing 5 by what is it? 100. Oh, is that 200? Yeah, 200. 150 milliliters plus 200 milliliters. So that's gonna get you 0.025. Okay, but no. Okay, so now we can find the pH, right? No, we can find the pOH. We can find the pOH of the thing because we're dealing with the OH hydroxide concentration. So that's going to be negative log of 0.025. That's going to equal, I believe that's going to equal 2.8. Plug that into your calculator. Now we can find the pH of the whatchamacallit, the no, that's actually going to equal 1.8. No, actually no. That's going to equal 1.6. I'm sorry, my bad. And now we can find the pH by using the relationship. pH is equal to 14 minus pOH. So 14 minus pOH, and that's going to be 12.4. So yeah. So it gets a little complicated because now we're dealing with hydroxide instead of H plus. So yeah, that's all you need to know really for these kinds of calculations. I mean, for these types of problems. And this is the easy kind. We're doing strong acid with strong base. Wait till you get to the weak acid and strong base, and then we'll really start working your mind. Well, until then, see you later. I hope you enjoyed yourself, and yeah, have a nice day. See you later.